All right, so let's graph and find the solution. So this is a line. My slope is 3. My y-intercept is -1. So that's where it's going to start. And then the slope up 3 over 1, up 3 over 1, rise over run. And so you can create your line just by doing that. It's solid because it says equal to. And now I need to test to see where I can shade. So do I shade on this side or do I shade on this side? And so you just take a point, any point that's not on the line. So in case 0, 0 looks easy, I can plug in 0, 0. That's false. So this side is false, which means by default this side is true. But let's verify it. What if I plugged in -1, 0? Sorry, +1, 0. That's true. You shade the side that's true. Or I can get out the super cool, like, shading graphy thing. Look at that. Yeah. For this next one, remember we still can deal with parent graphs. So that's absolute value. It has a horizontal shift of 2. So move it over 2. And then you can go through and you can start plotting the values for it. There's no equal to, so that means that your graph itself has to be dashed or dotted, because that symbolizes that you can't pick values on the line. And again, you test true or false. So if I plugged in 0, 0, 0, because it's not on the line. 0, is that greater than or equal to 0 minus 2? That's false, so this side is false. So that means this inside is true, but we can verify it. 1, 2, so that point right there, which is 2, 1. So is 1 greater than or equal to 2 minus 2? That is true. So that verifies that that's true. And so I can shade that part of the line. For the square root, now the domain we have to be a little bit careful of. So this is a reflection, so horizontal shift of 3. So 1, 2, 3, instead of it going up, it has a reflection. And it's dashed. Okay, so it's dashed. Now, there's a domain restriction. All of this part of the graph, there's no shading because it violates the domain. X values don't exist there. So you need to be careful about that. So the question is, which side of this graph am I going to shade? Is it this side or is it this side? So you can test a point. So what if I picked this value right here? 1, 2, 3, 4, 0. So let's test 4, 0. So I plug in 0 for y. Is that greater than or equal to -4 minus 3? Is 0 greater than or equal to negative? That's 1, so -1. That's true. So this side is true. So we're going to shade. Oh no. So questions here. What happens if you reflect an even function across the y-axis? So we explain it. If I take an even function, here's an example, and it reflects over the y-axis, it stays the same. What happens if I reflect an odd function over the y-axis? So here's an example of an odd function. If I reflect it over the y-axis, it is as if it either has a negative, like I replaced every x with a negative, or I multiplied my y values by a negative. What happens if you reflect an even function across the x-axis? So if I take that even function and reflect it over the x-axis, it looks like my function would just have a negative in front of it. What happens if you reflect an odd function across the x-axis? Again, if I took my odd looking function and I reflected that, it would look like this, which is the same situation here. So that would be, and we really can't tell the difference. And that's the definition of an odd function.